so back to the calculation. Sorry, I didn't want to bore you with pulling this stuff up, and it's easier for me to just get that going first. Okay, so here's the sample means that we derive a sample size 3, right, from the dice example, and I've got 8 of them in, so 3.3, and then our last two were 4 and 5, plus 4 plus 5, okay? And then we divide that by 10 because we took 10 samples. And what does that look like to you? So 3.86. Well, our true mean value we knew was 3.5, right? That's the structure of the probability of the dice. We know that if you rolled the dice an infinite amount of times, your average would be 3.5. But you can see even with small samples of 3 and taking the mean of those means, well, you're pretty close at 3.86. Now, just to illustrate that sample size example one last time, if you know that the true population mean mu is equal to 3.5. So if we know this value, and let's say we only take a sample of size 1, I get a 1, okay? How accurate is that? Well, it's not very accurate. I mean, it's a small sample size. Now let's take a sample of size 2. Whoops. 1 and 3. 1 plus 3 is 4 divided by 2. So here we get a mean of 2. Okay? Relatively close. I mean, I shouldn't say relatively close. It's just certainly much better than the sample of 1. Now let's say I rolled it 100 times. Well, it would be even higher. And really, if you think about it, I did 10 samples of size 3 here. But really what I did, if I was just taking a normal draw, this is one sample of size 30. And I ended up with 3.86. So the point is that the bigger sample size you have, the more accurate you're going to be. Again, that shouldn't be surprising to you. So the logic of the central limit theorem is that with repeated hypothetical samples, your sampling distribution of the mean is going to line up normally. It's going to have a normal distribution along the along the line, and it will line up normally on the true population parameter. Same thing with the standard error of the mean. With a larger sample size, you're going to have a smaller standard error of the mean. You're going to have smaller spread in the sampling distribution of the means. Again, I know it's really wordy, but it's nothing that you haven't learned before. We're just moving from a single variable and plotting the frequencies to taking means of a variable and doing it multiple times and plotting the means across a line and looking at the distribution of the means. Okay? So that's kind of it in terms of the sampling distribution and introducing. I mean, the key things you want to take from this are the mean of the sampling distribution and the standard error of the mean. Those are the two biggies. Next time on Thursday, we're going to be looking at we're going to be looking at estimation. So how to actually calculate the standard error of the means. We'll get more into that next time. So don't worry too much about the calculation for now, but just know that this has to do with the variability of the sampling distribution. And this has to do with the measure of central tendency, or the typical or average place for the sampling distribution. In real life, we never take multiple samples like we've done in the hypothetical example. The example in the book and the dice example is just there to show you that if we did take multiple samples, how the thing would work and how it would approximate a normal curve lined up around the true population mean, the population parameter of the mean, right? So that's kind of it. Like I said, the estimation stuff next on Thursday and Tuesday are kind of taking this logic and actually it's more mathematical. So for right now, it's not really any new math here as much as it is theory. So this is kind of the theory of statistics. So like I said, read the book, watch the YouTube videos, go back on my videos if you can bear to listen to this again. I apologize. These will get better as I go. And then lastly, if you have any questions, I'm available on Tuesdays and Thursdays from 1 to 4, and I'll just be sitting at the computer here at my house, as I've been for a week or so, and I'll we can address your issues specifically. Make sure you're keeping up with the syllabus. It's posted online or on BlazeView, so we have everything, due dates and everything are there for you. I will have your test graded by this evening. I'm sorry I haven't had those, haven't gotten those done yet. My apologies. I wanted to have those done earlier, but I'm going to, since you won't be able to correct them, obviously, because we're not on campus, I'll be curving those, which is something that I don't typically do, but I feel like since I promised you that you could correct, I feel like I at least owe you a few points, so I'll throw in a little curve there. And I'll post those up for you with the curve. Like I said, any questions, let me know. And otherwise, I'll see you guys virtually again on Thursday for some estimation fun, where we take these ideas and we calculate the actual standard errors. So how does a pollster get that a candidate A is polling at 52%, plus or minus 3? How do they know that? How do they know that that actually estimates the true value? That's what we'll do on Thursday. So this is just kind of the building block. So make sure you read into the central limit theorem, understand the logic, and then make sure you're understanding what the mean of the sampling distribution is and the standard error of the mean. These are important concepts moving forward. So that's all I got for you guys. Enjoy the rest of your afternoons, and hopefully I'll talk to you guys with some questions.